There is something out there. Something that, although invisible, has shaped the whole universe. Jan Conrad has his sights set on solving one of the universe's greatest mysteries. What is this thing we call dark matter? Think about this. Our sun is one of hundreds of billions of stars which make up our galaxy, the Milky Way. And the entire universe, in turn, consists of hundreds of billions of galaxies like ours. Scientists now believe that it is dark matter which has clustered celestial bodies in this way, by virtue of its enormous gravitational force. But what the universe's invisible skeleton, dark matter, actually consists of is still a mystery.
My goal is to understand what dark matter is. Our current understanding of the universe is not complete because our current understanding does not contain dark matter particles. First, if we know what it is, then we can make our understanding of how the universe started, evolves, and will end more complete.
When he was 8 years old, he could rattle off the length of time it took every planet in our solar system to orbit the sun. At 17 years of age, he was invited to be an intern at the world's foremost physics lab, CERN. Jan has always known what he was going to be.
Already as a small child, I was sort of into research, and trying to solve difficult problems was always something fun to me.
So today, naturally, Jan Conrad has taken on the task of solving a sort of big problem.
We know that dark matter exists because it has influence on normal celestial bodies like the Earth or the galaxy by its gravitation. We can measure the velocities of the different celestial bodies and thereby conclude that there must be a large amount of dark matter which we cannot see otherwise.
Scientists' calculations conclude that dark matter may consist of what is called a wimp-particle, or WIMP, which stands for Weakly Interacting Massive Particle. This proposed WIMP particle is much heavier than normal particles, and yet it can travel unnoticed right through ordinary matter. This is why it is sometimes referred to as the ghost particle.
A WIMP is a very heavy particle, a hypothetical one that we invented because it has the properties that dark matter should have. A very heavy particle that does not really collide with normal matter.
To prove the existence of WIMP particles and solve the riddle of the universe's dark matter, researchers are looking in the last place one might think of, as far away from space as possible. This is what brings Jan Conrad now to the Apennines Mountains in Italy. Herein lies the world's largest underground physics laboratory, Laboratorio Nationale del Gransasso. This is where scientists from around the world come to detect different particles. The mountain protects the lab from cosmic radiation that would otherwise interfere with experiments elsewhere. The lab is located almost 1.5 kilometers down under the mountain, in the middle of a 10-kilometer highway tunnel.
The reason is that we have a huge number of known particles that all the time will interact with this detector that we built to detect dark matter. And this is sort of rubbish, you know, this is things which flood our detector, but we have no use for it. And to get rid of this rubbish as much as possible, we have to shear the detector from these other particles, and this is why we go deep underground.
Here, researchers can rig up their particle traps with as little outside interference as possible.
Xenon.
Jan leads a small scientific team who are daily performing experiments down here in the Gran Sasso lab. Most of the time you'll find Jan at Stockholm University, where he analyzes the data. But occasionally he visits the location in Italy to monitor the work on site.
Well, it's now very noisy, yeah?
It is, but...
Så det är vår detektor som vi försöker hitta mörk materia med, som finns inuti det här materialet som är runt omkring som skyddar för partiklar som kommer utifrån. Och då mäter vi hela tiden signaler som vi kan se på den här lilla oscilloskopen som är här nere.
Dark matter is everywhere, all around us. But it has been impossible to detect because it very rarely interacts with ordinary matter. Sometimes, though, it happens, and when it does, Jan is waiting.
If we imagine that this is the dark matter particle and this is the xenon atom, the dark matter particle will be coming here, and sometimes it will collide with the xenon atom, which then moves away, and as it moves away, it gives rise to light that we can detect in the detector inside here.
Inside the particle trap, the noble gas xenon is used as bait. The xenon atom is the same size as the proposed particle of dark matter, and should be more likely, therefore, to easily interact with the particle. Scientists hope that the WIMP particle will collide with the xenon atom inside the detector, resulting in an electrical signal that would be captured, revealing the dark matter.
So here we can see the signals which come out of the detector, which are caused by particles that interact in the detector. And so here we really can see if there is a dark matter particle coming and interacting in the detector.
So far, Jan Conrad and his colleagues have not gotten any signs. But their hopes are increasing. Now, an even bigger and better detector is being built at the Gran Sasso lab.
So, here you go.
It's fantastic.
That's the impressive
If the ghost-like WIMP particle really looks like what the physicists calculated, Jan Conrad believes that he and his team will find it within the next 10 years.
You know, dark matter has been discovered in the 30s, so 80 years ago. Since then we know there is this component, you know, which is dark matter, which we don't know of. So it has been around for some time, this problem. And to be, you know, an active researcher in a period where actually the detection of dark matter particles could happen, where we have a good chance to do it, is of course very exciting.
Within the next few years, Jan Conrad and his colleagues may be the first to understand what the universe's invisible skeleton actually consists of. A discovery that, additionally, many believe would warrant a Nobel Prize, and thus would reveal to us new knowledge about the universe's birth, its development, and its end.